Assalamualaikum and hi. This is chapter 6 air conditioning video part 1. In this video, I'm going to explain two subtopics. The first one is air conditioning system and the second one is dry and atmospheric air. Thermodynamic application. In thermodynamic application, we have thermodynamic cycle and we have power generation and also refrigerations. And we already looked into chapter 5, which is the refrigerator. Now we look into the chapter 6, which is the air conditioning system. Air conditioning system. Split unit air conditioning system. This is the one example of the split unit air conditioning system. And from the simplified diagram, we know that we have this indoor unit and also outdoor unit. The indoor unit is where the cold air being released or being blow into the space, and the hot air is the location where the heat is released to the surrounding. And from the simplified diagram of the air conditioning system, we know that the component of the air conditioning system, which is the evaporator, placed at the indoor unit, compressor, and then condenser, which is at the outdoor unit, where the hot air being blown to the surrounding, and last one is the expansion valve. So these four is the main components of the air conditioning system. Central air conditioning system. Okay, we already looked into the split unit of air conditioning system, which normally being used for to condition a small space area. And for central air conditioning system, it normally being used for large air conditioning room or normally being used in a large building. So as you can see, for the central air conditioning system, you have one central air conditioner and also one cooling tower that control the temperature or that chill down the air throughout the building. And this is a simplified diagram of the central air conditioning system. As you can see, we have one cooling tower here and goes into the condenser and also compressor supply to the AHU that control the humidity and temperature before it being supplied to the condition room. This is another example of the central air conditioning system, and the same system being applied where we have a air handling unit here that control the temperature and condition the air uh, as per the air conditioning room, and you supply to the air conditioning room from the air vent or the ducting. Central air conditioning system, air handling unit. So this is a simplified diagram of the AHU along with the supply and also return duct. And as you can see here, this is the air handling unit and this is the supply duct. And this is the return valve, return duct. Sorry. And this is the AHU. And also this is the simplified diagram of the AHU. And in AHU normally we have a cooling or heating element, blower, filter rack or chamber, and also damper that control airflow into the conditioned room. Dry and atmospheric air. Dry and atmospheric air. So before we go further into the air conditioning system, first we should know what is the composition of the air. So naturally the air consists of most of it consists of nitrogen, and a quarter of it is oxygen, and the rest of it is neon, argon, kryptons, carbon dioxide, and also water or H2O, which is the small portion of it. And let's say we have all the content of the air, but we do not have any water content inside it. So this kind of thing is called dry air. And for the cases we have all it, and we also have H2O, which is also referred as the water vapor or moisture content, and this is the atmospheric air. So to design a air conditioning system, we should consider both of these atmospheric air and also dry air. So air is actually a mixture of the dry air and also water vapor, and dry air is relatively constant. However, for water vapor, it changes due to the condensation and also evaporation. And this water vapor also influence the human comfort in a space. Dry and atmospheric air. This is the composition of the dry air, which is I got this information from this link, and from this we know that the mole percentage of nitrogen is the highest, which is 78%, followed by oxygen, which is 20.9%, and then argon 0.9%, and carbon dioxide is 0.03%, and the rest is extremely small portion, less than 1%. This is the end of part 1 for chapter 6. Thank you, and hopefully you enjoy my video.